Um, I mentioned yesterday that geometry has essentially been unchanged since 300 BC, when Euclid put together the first math textbook ever, which was called the Elements. And the basis of all geometry starts with these first four. Okay. Um, in geometry, we have postulates, and we have definitions, and we have theorems. But we also have things that are undefinable or undefined. And what we mean by undefined is it's not defined, it's only described. And they are not really provable, undefined terms. So when we look at point, which is our first undefined term, a point has no shape or size. It's infinitely small. But it represents a location in space, and we represent it by drawing a dot. But technically, our dot, our tiny little dot, the period that you put on your paper at the end of a sentence, has an infinite number of points in it because they're just that itty bitty. And we can't really define them, we can only kind of describe them. And to describe them, you say they have no shape, they have no size, they're just a location in space, and they're, you know, smaller than even the smallest part of an atom. And we have to just kind of accept that that's true, because we can't prove it. We can't prove they exist. We can't see them. We can't test for them. They're not a real, necessarily, thing. They're an idea. And it's the same thing with a line. What you and I draw on a piece of paper and we call a line is actually just a line segment. And it's technically it's too thick to be a line, because a line is a string of points. So like if you think about a necklace that's made out of beads, and the beads all go together and then they make like a long string. Well, if the beads were the points, the string of the beads would be the line. Except because the points are infinitely small, the line is infinitely skinny. So you can't even really see it. So we just have to kind of accept that it's there and that it exists. And if you take that necklace, that string of beads, and you strung it out and it went forever, it would be like one long string going on and on forever in two directions. And that's a line. And then you have a plane. Again, this can't be defined because it's made up of points, which are infinitely small. But if you took a piece of paper, and you guys have seen that artwork that's made out of dots, pointillism, and you covered the entire piece of paper with dots and just filled it up completely, and you know, you were using black ink, so now the whole piece of paper is solid black. That's kind of the idea of a plane. So it's like a piece of paper, but that goes on forever, but it's flat, like a piece of paper. And it's just made up of points and of course lines, because the points make up lines. And so the plane is just points going left and right and forwards and backwards and diagonally, and just filling up that whole space as if you were to take the dots and color in the whole page with just dots. Does that make sense? And again, because it's got no height, because the points have no height, you can't really see it. We can't really test for it. You just have to kind of accept that it's true. And pretty much the whole basis for geometry builds on these three things: points, lines, and planes. Everything else, every shape, every three-dimensional figure, everything is made of points, lines, and planes. Angles, rays, everything. So while we can't actually see them and while we don't actually know they exist, we accept this is true. And then we move on. And that allows everything else to happen. We represent a point with a dot. We represent a line with like a little tiny piece of a line with arrows on the end to show that it goes on forever and ever and ever. And then we represent a plane by drawing a parallelogram, which is just, you know, a squished rectangle off to the side. Okay, and then we have collinear. This is an actual definition. And collinear are any points that lie on the same line. So if I have a line here and here, this point and this point are collinear. Any points on the line are collinear. And then you have the opposite of collinear, which is called non-collinear. And if I have a point, say here, that point would be non-collinear because it's not on the same line. And then we have coplanar, which is another definition. And we have points or lines that lie on the same plane. So if you have your piece of paper and that's a plane and you draw some lines on it, they're on the plane. So they would be coplanar. And you could draw a dot and a line on it, they'd be coplanar. But if I took a different piece of paper and I had one piece of paper with a line on it and then this other piece of paper up above it with a line on it, these would not be coplanar because they're not on the same plane. It's really hard for me to draw that, so I'm not going to try. So the opposite is non-coplanar. Okay, and then space. Not only the final frontier, but it's boundless. It's the 3D set of all points, and it contains points, lines, and planes. And if you think of a box, but that it goes on forever, it's just, well, it's like space, you know, just, it's, as far as we know, just goes on forever in every direction, right? Except it's full of points and lines and planes. Plane is, knowing what they are is all well and good, but you have to be able to talk about them. So to be able to talk about them, we have to be able to name them. And we name them based on their points. Okay, so lines are named with 2 letters. Okay, so we use 2 letters with a double arrow over top. Okay, so here's the line that contains the point W. It has 3 letters on it, 3 points on it. So I can actually name this VW, because, you know, I like Volkswagens. Or I can name it WV. The order doesn't matter because the line is infinite. I can name it VY. Oh, it has 4 letters on it. Sorry, I missed that X. I can name it YV. Or WX. Or XW. Or VX. Or XV. Or XY, or YX. What combination did I miss? Y. No, I got YX. I missed YW. Or WY. Okay, so this one line can have all of these names. And that's because we have 4 points on it. So if you look, we have 1, 2, 3, 4, 5, 6, 7, 12. Can I get VY? Is that VY? VX. Is that VX? Yeah, okay. I think I got them all. Let me pause. Okay, so any of these names, if you use them, would be correct. There is not one correct name for this line. Now there's also one other name that we can name this line. Do you guys see this little tiny n right here, lowercase, that's not attached to a point? We can also call this line n. So if you use the little lowercase letter, you do put the word line in front of it. So lots of different correct names for lines. Lines use 2 letters with a double arrow. A plane contains 3 letters. And the word plane. I'm going to write it up the side of the plane actually. Okay, and the word plane. So the easiest way is, you see this P in the corner with no point on it? You have a capital letter in the corner of a plane with no point on it, that's the name of the plane. So the easiest way is to call it plane P. Or we can use any 3 letters that are on the plane. Now this T is not on the plane, but all of these other letters are on the plane. So we can use any combination of those 3 letters. So we could have plane VWX or plane ZYB, etc. I'm not going to write them all because there's a lot. But any 3 of these letter combinations. And they can go in any order. Okay, so these 2 same letters, different order, still a legitimate name. So if you have points on the plane, you can pick any 3 and put them in any order, and that's the name of the plane. Well, one name of the plane. Okay. Now we have what says a plane containing points T and Z. T is here, Z is here. The T is not on the blue plane that we have drawn. So we have to create a new plane. We can have a plane that goes through T, Z, and X. We could have one that goes through T, Z, and V. A plane can go through any 3 points. So we can pick any one of the other points, and that can be the name of our plane. So I could have, oops, not plane TZX. I could have plane TZV, TZW, etc. Just so long as T and Z are in there, because it said we had to have T and Z. Any other letter is okay. If there are a bunch of different planes, you know, they would be kind of like, you know, one would be sitting maybe like this and one would be sitting kind of, you know, this way, or they might cross each other, which I can't, not magic, but you get the idea. Okay. And then we have the line containing point T. If we go, we have this line here. So we could call this TX. Or we could say line R. And this is the obvious line because that's a line that's drawn. But technically a line can go through any 2 points. So if I wanted to, I could draw this line right here. And I could have line TZ. So when you're talking about these things, there's infinite number of points in the, you know, existence, but you basically have freedom to use any of the points that are here. So I could have line TZ, line TV, TW, TY. I just wouldn't have a little letter name for that one, for those. Okay, what we have is to name the line that contains point E, and that line is right here. And I had 3 possible names for that line. Oh gosh, can you guys even see that? Yeah, here, I'll just write them on here. Okay, we had line Q, line BE, well, sorry, you don't write the word line. BE, for some writing in Pennsylvania, can you guys see it? And then you could say EB. Any one of those would have been correct. Okay. Our next one was name a point contained in line N. And line N is this line here. So we had 2 points. You could say either B or A. Either one is correct. Or, you know, you name both. Okay, another name for line P. Yep, CD. Or you could say DC because the order doesn't matter. If you're talking about a line, yes. So when, I'll just go over that really quickly. So if you have a line, you have the 2 letters with the arrows over top. If you have a line segment, so that's like a piece of a line, something like this. So that was D and C. You put DC with a bar over top. And that indicates that this is a line and this is a segment. And then when you have array, you put the single arrow. And then this point is the end, so whatever point doesn't have the arrow is the point, you know, is the letter without the arrow on the writing. So if it went like this, where it was C and then D, you would put the CD with the arrow. And that's just, that way, it's kind of annoying, I guess, to have to put the lines and stuff on top, but if you didn't, you'd have to write line, DC, segment, DC, ray, so this is actually shorter. Okay, now for the planes, let me see if I turn the light off if that's better. Oh, can you guys see that better? No glare, maybe? Hold on. Okay, fine. I have CDA here, and then every combination of that, CAD, ADC, ACD, DAC, DCA. Okay, so there's also plain G because there was the G. Then I have ADB and every possible combination of those 3 letters. And then I had the combinations of C, A, and B. And then the combinations of C, B, and D. And if you wrote down any of these, you are correct. Will I ever make you write down all of them? Absolutely not. So you put the word plain in front, and it could be any of these combinations of letters, any 3 letters, and you had a correct answer. So as you can see, there's lots of correct answers. So there's actually 1, 2, 3, 4, 5, 6, 25 possible correct answers for this one question. Grading the test is so fun. I can't have an answer key. I just have to look and see if you got a right answer. Any questions on that? So like I said, just, you would never have to name all of these. I might say name 3 ways to name this plane or something like that, but I will never be name every way to name this plane and have you write out 25 different things. It's not, that would be a whole test. Okay, so next thing we want to discuss is intersections. Okay, so the intersection is the set of all points that two geometric figures have in common. And that intersection will be one dimension less than the smaller figure. Okay, so we need to talk about dimensions. A point has no shape, no size, no length, no width, nothing. It has 0 dimensions, so it's 0 dimensional. A line has direction in 2 ways, goes right and left forever. But it is one dimensional because it has length, not measurable, but has length, but it doesn't have width or height. So one dimension. A plane, which is a piece of paper, has length and width, but no height because it's flat. So that's 2 dimensions because it has length and width. And then a box or any other 3D form has length, width, and height, so it's 3 dimensions. So if we have 2 lines intersecting, they intersect at a point. The lines are one-dimensional. Their intersection has 0 dimensions. So 2 lines intersect at a point. 2 planes, well, I'm sorry. 2 lines intersect at a point, or they overlap as a line. Okay, so if you have 2 lines and these are your lines and they intersect like this, they're intersecting everywhere, so they create another line. 2 planes intersect to form a line. A line in a plane intersects to form a point. 2 planes can also intersect to form a plane if they intersect everywhere. So they're like flat, two planes come together and they lay on top of each other and they're just flat. So they intersect everywhere. So that would make a plane. But if this plane's coming along and this plane's coming along and they intersect like this, you can kind of see how it would make a line. You'll notice I copied these pictures off of the internet because I can't draw them. There's also, if you have 3 planes come together, 3 planes will intersect to form a point because there will only be one point where all 3 planes meet. Okay, lines A, B, and C, D intersect at E. A is -2, 4, B is 0, -2, C is -3, 0, and D is 3, 3 on a coordinate plane. Point F is coplanar with these points, but not collinear. So we want to draw that. Okay, so the first thing we do is we plot our points. A is -2, 4. If you want some graph paper, I have some on the cubbies over there. B is 0, -2. C is -3, 0. And D is 3, 3. And we want to label those. So this was, oh, darn it. See, I told you my pen doesn't like me sometimes. So this was A, B, C, and D. Okay. My pen won't cooperate. I will cheat. There's line CD. There is line AB. And then it says that they intersect at point E, so we draw a point right where they intersect and we call it E. And then it says point F is coplanar, but not collinear with either line. That means that F can go anywhere else except except on the line. So we could put F up here, we could put F over here, we could put F here, we could put F here. I'm just going to put it over here because why not? That it's on the same plane, because this is a coordinate plane, right? So that's a plane. So it's on the same plane, but how it says it's not collinear, so it's not on the lines. So again, now for this exact example, you had to put A, B, and C, D where they are because we had coordinates for those points. And then we had to put E where it is because it had to be where the intersection of those are. But F could go anywhere. So as long as it wasn't on the lines, you'd be correct. So again, lots of possibilities for drawing these. Sometimes we're not as specific. It says QR intersects plane T at point S. So when we draw a plane, oh here, you know what? I'm going to cheat for that too. I have this great cheating tool. It's called shape recognition. Here's my plane. See, it's all pretty now. Okay, my plane is called plane T. So I put a T. Oh wait, I'm still on shape recognition. That's why. I put a T in the corner. Okay. QR intersects plane T at point S. So I can draw any line that's going to intersect the plane at a point. It can come in like from this way. It can come in from this direction. I usually do that to show that it's going through. And then I sort of dot it, you know, like so you can kind of see that it went through. You put a point Q, you put a point R to be line QR, and wherever you hit the plane, you call that S. But again, there's lots of ways you could draw this. The only thing you would not want to do is draw a plane and put the line right on it, because it's intersecting at a line at that point, because the line is sitting on the plane. So the line has to like puncture the plane to intersect at a point. Does that make sense? Okay. So not this, something like this. But again, as long as you draw a parallelogram with a T on it and you have some line from some direction going, like puncturing the plane, it didn't say it intersects plane T from the northeast at 30 degrees, or, you know, it's not that accurate, you know, it's not that exact. You just draw some plane with some line and then label it. Okay. Okay, so let's go over this. For number 5, I drew a line and I have an R and a K and a T on it, and I just happen to put them in that order. But if you have a dot, 3 dots and those 3 letters in any order, you are correct, as long as they are all on the same line. Okay. My plane, I wasn't really sure what letter that was supposed to be, so I just sort of tried to draw it the way it looked. I have no idea. What is it? Is it a J? Okay. So as long as you have something that looks like a parallelogram with something that looks like a J in the corner, and you have a line with 2 arrows and there's a little S on that line somewhere, doesn't matter what direction the line is facing, you're good. Then we had, YP lies on plane B. So I have plane B with a line on it with YP, and then it contains point C. So I put line C, or point C on line YP, but it does not contain point H, so I put point H not on line YP.
Doesn't matter the order on the line.
No, on the line these can be in any order, and this point H could be anywhere on or off the plane. It didn't say that the point was on the plane. It just said it wasn't on the line. So as long as you have an H somewhere on there, it could be over here. It just, so long as it's not on the line, you're good. Okay, and these 3 points can be in any order. And then I have lines Q and F intersect at point Z in plane U. So I drew my lines, and those lines can intersect at any angle and any spot, just so long as you labeled it Z. And you put a U over here somewhere. Any questions about that? Yeah.
So on number 7, when it says,
So, not really. Okay. Actually, I'm not going to highlight them. This won't record well, but that's okay. Alright, so we have this hexagonal pyramid. You guys will learn how to name these in a minute. We have 1, 2, 3, 4, 5, 6 sides on the bottom, right? Each side has 3 points. 3 points is a plane. So each side of the pyramid going out around the top, or going up to the top, is a plane. So we have 6 planes on this pyramid, and then we have the plane that it's sitting on. Okay? Does that make sense? So every side of any 3-dimensional shape is a plane, except for spheres. They're in their own little world. Okay, so we have 7 planes. Oh, now I should use a pen, not a highlighter. Okay, so 7 planes. Okay, and we want to name them. So we have the front here, HDG. Oh, come on. So we have the top point B, which I know you guys can't really see very well, but you've got the top point B. And we have the front of the pyramid, so DH and G. And that could be in any 3, any order. Then you have this side here with G and F. So we would have DGF. And then you have the back here with E and F. The plane that makes up the side is K and E. We have the JK side. We have the HJ side. Now, if I was being correct, I would put the word plane in front of all of these, but I have space issues, so I'm just listing. And then finally, we have the plane that's on the bottom that the pyramid's sitting on. And that could be any combination of any 3 of these letters on the base here. But I'm just going to call it plane X. So that's going to be easy. C, it's on the line JD, so I could use C in the plane DKJ, because it's on that line, or DK, or DHJ, because it's on that line also. So I could use that letter instead. But I'm just trying to keep it simple right now. So I have plane X. So you have each of the sides, and then the bottom. Okay. 3 points that are collinear. Well, here's the thing. I have AB, right? But there's no 3rd point on that line that I've got named. None of these 3 points are all collinear because they bend. The only 3 points that are collinear are going up this side J. So we have J, C, and D. Yeah, they can go anywhere. Okay, we're going to name the intersection of plane HDG base. So what we do is we look at the thing that's intersecting. So if this plane was going on, it's hitting at this line right here. So the intersection is going to be line HG, or you can call it GH. So when the two planes hit, they'll hit at a line. Okay, and then we say at what point do line AB and line EF intersect? So we have line EF here and line AB here. And if you look at this picture, they don't look like they intersect. However, lines extend. And go on forever. So if I take this line EF and I extend it out, it hits at point B. Okay, because we're talking about a line, and so we have to keep in mind that it will continue and go on forever. So we want to draw it longer and see where it hits. So it hits at point B. Okay, we have our points E, D, F, and G coplanar. So I have E, D, F, and G. E, D, and F make up this like skinny side that we can't really see that's kind of around the corner of the pyramid. And G, F, and D make up this side of the pyramid. So if we had those two sides, they're kind of like this. And then there's this point up top. That's two different planes. So they're not going to be coplanar because they're on two different planes. Does that make sense? So the only ones that will be coplanar are if all 3 points or 4 points are on the same side of the pyramid. But because you're covering two sides of the pyramid, you're no longer coplanar. And then E, G, and F would be coplanar because on the flat part, but since you added D up top up there, it doesn't work anymore. Two different planes. So we just say no. And then we have at what point or in what line do planes JDH, that's this side here, JDE, that would be a plane that kind of cut the pyramid down the center. Because any 3 points could make a plane. And EDF intersect. What point? They have 1 point in common. Point D. That's the point that they all have in common. That's where they would all intersect. So if we were to take this figure and had this side and this side, and then we put a piece of paper in between them, touching, the only thing that they would all have in common is the top point. Does that make sense? All right. Oh gosh, I kept you guys late. Sorry. Homework tonight.